this section, we're going to solve polynomial and rational inequalities. So let's go ahead and start with the polynomial inequalities. And here are the steps that you can use to solve polynomial inequalities. Number one, rewrite the inequality with 0 on one side. Number two, solve the equation when it's equal to 0. So you're going to set it equal to 0 instead of having it be greater than 0 or less than 0 or whatever. And you're going to find the zeros that correspond to that new polynomial that you've created. Step 3 is to create a sign chart with the zeros as the partition points. These zeros are going to denote the places where the polynomial can change signs. And when the polynomial is positive, that represents greater than 0. And when the polynomial is negative, that represents less than 0. Step 3, test each interval to determine if the polynomial is positive or negative. And it's usually easier to do this in factored form. And then number 5, use the information to solve the original inequality. If you're looking for greater than 0, then those are positives. Less than 0 is negatives. And then use the less than or equal part, the equal part of that, to denote if it's going to be an open interval or closed interval. Let's take a look at some examples. Number 1 is solve x squared minus 6x plus 8 is less than 0. So the first step is to make sure that you have 0 on one side, and that's already done. So check. Number 2, we want to create the equation that's based on this polynomial. So it's x squared minus 6x plus 8 is equal to 0. And we want to find the zeros. So this one factors as x and x, and 2 and 4, and they're both negative. So we get x minus 2 times x minus 4. Set each factor equal to 0 and solve. So we get x equals 2 and x equals 4. Step 3 is to create a sign chart. So the sign chart here is going to contain x equals 2 and x equals 4 as the partition points. We put on top of the sign chart little zeros to denote that these came from zeros. Now that's not as important on the polynomials because they're all zeros, but when we get to the rational parts, there could be some that are points where it is undefined. Step 4, we need to do testing. Now there's a couple of ways that you can do the testing. So the first way is to pick numbers inside each of the 3 intervals that are created. So I'm going to pick x equals 1, x equals 3, and x equals 5 to do the testing. And when I test those, I test them in the polynomial. So it would be x equals 1. Let's see what that gives me here. And I'm going to use the factored form. I'm going to use this form right here. This is the same as this original form here. And you have to use a form that was related to the inequality. Well, this is exactly the polynomial that was listed in the inequality part. So I can use the factored version of that. Sort of makes the math easier to deal with. I'm going to plug in 1 for x, every place I see an x. So we get 1 minus 2 times 1 minus 4. And that's equal to negative 1 times negative 3, which is equal to positive 3. Now, realistically, I don't even care what the number is. I just want to know if it's positive or negative. And in this case, it is positive. So we get a positive sign in the entire interval. So this is a situation, once again, where we have found the partition points, meaning the points on the graph where the behavior of the graph can change. In this case, it changes from positive to negative or negative to positive. Since those points are the only points where it can change, if I find the sign of one point inside an interval, then I know that the sign of every point in that interval is also the same sign. So the sign at x equals 1 is positive. So the sign of every point from negative infinity to 2 is also positive. Let's test at x equals 3. And this would be 3 minus 2 times 3 minus 4. Now I'll show you a little trick here. Since we don't care what the number actually is, all I need to know is what the signs are if I'm doing multiplication. If you're doing addition and subtraction, then you have to actually work out the numbers. But with multiplication and division, all I need to know is what the signs are. 3 minus 2 is a positive. 3 minus 4 is a negative. And a positive times a negative is a negative. So we have negatives between 2 and 4. And then I'm going to test x is equal to 5. So this would be 5 minus 2 times 5 minus 4. And that's a positive times a positive, which is a positive. And so we have positives over here. That completes the sign chart. The last step of this is to use the sign chart to determine the intervals that match the original inequality. The original inequality is less than 0, which means I need the negatives. The negatives for this function occur between 2 and 4. So it's going to be 2 to 4, and it's the open interval from 2 to 4. Because there is no equality part on the inequality. It's strictly less than 0. And that's it. If the question had asked for greater than 0, then we would have used the positives. If it had asked for less than or equal to 0, we would have used this interval, but we would have closed it at 2 and 4, because where x is equal to 2 and x is equal to 4 is where the function is equal to 0. Example number 2. Solve 3x cubed minus 4x squared is greater than or equal to 75x minus 100. So step 1 is to get everything on one side and have a 0 on the opposite side. So I'm going to move the terms on the right to the left, and they come over as a negative 75x and a positive 100. Step 2 is to create the equality. So we have 3x cubed minus 4x squared minus 75x plus 100 is equal to 0. And now we want to solve this equation. Well, I notice right away that this is an equation that will factor by grouping. So I'm going to group the first two terms and the second pair of terms. From the first terms, I can factor out x squared, and that leaves me with 3x minus 4. And from the second terms, I can factor out a negative 25. That leaves me with 3x minus 4. Factoring out the 3x minus 4, that leaves me with x squared minus 25. And then x squared minus 25 factors as x minus 5 and x plus 5. Setting each of these factors equal to 0 and solving gives me x equals 4/3, x equals 5, and x equals negative 5. Now let's put a little box around this because I want to use this factored version here in a moment. I'm going to use that for something else. So let's keep track of that. Let's go ahead and create the sign chart. Now the sign chart is a number line. So you need to put all the numbers in numerical order. So it goes -5, 4/3, and 5. And now let's pick a number to test. I'm going to test at negative 10. Why not? It just has to be a number between negative infinity and negative 5. And if I test there at negative 10, then we get the following. 3 times negative 10 minus 4 times negative 10 minus 5 times negative 10 plus 5. This is equal to negative 34 times negative 15 times negative 5, which all I care about is that it's a negative times a negative times a negative. 3 negatives multiplied together gives me a negative. So the interval, let me put up my zeros. So the interval from negative infinity to negative 5 is all negative. Now, another way that you can complete the sign chart after producing one of the signs is based on the multiplicity. So recall that if the multiplicity is odd at a 0, then that crosses the x-axis. And if it is even, then it just touches but stays the same on the same side of that axis. Well, when we're dealing with sign charts, what that means is that if the multiplicity is odd and it would cross the x-axis if we were to graph the function, then that means the sign changes. And if the multiplicity is even and it merely touches the axis and stays on the same side, then that means that the sign stays the same. And you can use that information to fill out the rest of the sign chart. So notice what the multiplicities of each of these roots are. They're all 1 because the factor that produced each of these had an exponent of 1. So these multiplicities for all 3 of these numbers are odd, which means that the sign changes every time you hit one of the zeros. So from negative infinity to negative 5, it was negative. Then it's going to change and cross over here. So it's going to be positive between negative 5 and 4/3. Then we cross another 0 and it becomes negative. And then we cross another 0 and it becomes positive. Now don't get too caught up on the fact that all of these examples we've done so far are alternating, positive, negative, because they don't have to do that. All you have to do is have a multiplicity where it is even, and then it would stay the same for that next interval. 2 intervals would be the same sign. But that is the shortcut that I like to use to complete the sign chart. You're welcome to do either one. If you want to test 4 or 5 values, go for it. Now we have to solve the original inequality. The original inequality was right here. Now don't get confused by this. This is now the polynomial that we're solving, not the original one. Because the first thing you have to do is you have to move things over and have it compared to 0. So what is it compared to 0? Well, we want the polynomial to be greater than or equal to 0. So that means we want positives or 0 themselves. So where on my sign chart was it positive or equal to 0? And that's going to be at negative 5, and it's closed at negative 5 because it does include the 0, so it's negative 5, up to 4/3, and it does include 4/3, union, then it picks it back up at 5 and goes to infinity. And we always use a parenthesis when we do infinity signs. So that's the answer right there. Example number 3. The head count, H, of cattle on a large South Texas ranch can be modeled using the following quadratic. H of t is equal to negative 0.2 t squared plus 73t plus 300, where t is the number of days since March 1st. How many days throughout the year does the head count exceed 4,000? So first we want to interpret the problem and create an inequality. It's an inequality because of the word exceed. That means it's bigger than this particular number. So we want to create h of t is greater than 4,000. So that would be negative 0.2 t squared plus 73t plus 300 is greater than 4,000. Our first step in solving this inequality is to move the 4,000 over to the left side to create a comparison to 0. That combines with the 300 to create negative 3,700 is greater than 0. Now we create the equality and we get negative 0.2 t squared plus 73t minus 3,700 is equal to 0. And then we solve for t. Well, this one doesn't look like it's going to factor very easily. It's got decimals, it's got rather large numbers. So I'm going to use the quadratic formula. The quadratic formula tells me that t is equal to negative 73 plus or minus the square root of 73 squared minus 4 times negative 0.2 times negative 3,700, all divided by 2 times negative 0.2. And when you work that out, you get t is equal to 60.82 and t is equal to 304.18. Now we still need to do a sign chart to determine where it is greater than 0, where it exceeds the 4,000 cattle. So we create a sign chart. Now we got to be a little careful in this sign chart. T represents the number of days since March 1st, so it can't go beyond 365. And it can't go before 0. So you're not allowed to use any number less than 0 and anything bigger than 365. We'll go ahead and put our zeros on the time, on the number line here. And when you test this, you do get that it's negative in this first interval, positive in the second interval, and negative on the last interval. And since we were looking for greater than 0, it does tell us that it is between these 2 days here. So however you might want to phrase this, or however it might be asked on the computer or on a test or something, basically the result is this, that it is between the 61st day and the 304th day. And that's where the cattle exceeds 4,000. Let's take a look at the steps for solving a rational inequality. Step 1, follow the same steps as when you solved for the polynomial inequality. There's a couple of differences. Number 2, the partition point should include the zeros of the rational function and any point that is not in the domain of the function, because when you set the denominator equal to 0, you get an undefined value at that x value. Number 3, create the sign chart with the zeros as the partition points, and let's put in this, and the points where the rational function is undefined. So it's not just the zeros, it's more than just the zeros. Then step 4, test each interval to determine if the rational function is positive or negative. We can use the same sort of sign chart techniques that we used before with the multiplicity. So you can put that in here as well. Use multiplicity. And then solve the original inequality. Example number 4. Solve the inequality x minus 3 over x plus 1. So it's already compared to 0. So step 1 is done. Step number 2, we need to find the zeros. The zeros of a rational come from setting the numerator equal to 0. So that's x equals 3. And we also need to find where it's undefined. So we set the denominator equal to 0, and that's x equals negative 1. Step 3, we're going to create the sign chart. So the sign chart has negative 1, and that is a point where it is not defined. So we use ND. And a point where x is equal to 0, as x equals 3, is a 0. And step 4, we do the testing. So here again, you can do testing or you can do multiplicity stuff, but you do have to start with one of them. So I'm going to start with x equals 0. So this would be 0 minus 3 over 0 plus 1. That's equal to negative 3. And so that's negative. And so where x is equal to 0 is an interval where the function is negative. And you can continue to test these other points that you can find, or you can look at the multiplicity. The original function had these factors with multiplicity 1, so they were all odd. And so that means it's going to change whenever you cross over one of these. Now, the rules for multiplicity work for zeros or the factors that created the undefined points, like x plus 1 in the denominator. So when I cross over at x equals 3, it does change it to a positive. And you can cross backwards too. You can cross going backwards over here. So it was negative, and then when I cross backwards over negative 1, that changes it from a negative to a positive as well. And now we can solve the question. It said, where was it less than or equal to 0? So less than or equal to 0 is negative, and it includes the zeros. So the numbers on the number line are negative 1 and 3. And it was 0 at x equals 3. So the right side gets a bracket. But at x equals negative 1, it was undefined. It was not equal to 0. And it's not even defined there. So it's going to be an open parenthesis at x equals negative 1. And that's the answer. So make sure you get the difference between the open parenthesis and the square bracket with the equality. Make sure you get those down because those become very important. In example 5, we want to solve this inequality. X squared minus 4 over x squared is less than 0. So step 1 is to make sure everything is on one side with a 0 on the other. Chuck. Number 2, let's find the zeros of x squared minus 4 by setting the numerator of the rational function equal to 0. This factors as x minus 2 and x plus 2 equals 0, giving us x equals 2 and x equals negative 2. Let's find the x values where the rational function is undefined. We do that by setting the denominator equal to 0. And we get x is equal to 0 with multiplicity equal to 2. Because it was x squared, that gives me x equals 0, but the power gives me the multiplicity. And that's going to be important whenever we do the sign chart, which comes up next. So let's place all of our partition points on the sign chart. So we have -2, 0, and +2. -2 and +2 were zeros, and x equals 0 was a point where the function is not defined. Let's do a test. I'm going to test at x equals 1. So testing at x equals 1 gives me 1 squared minus 4 over 1 squared, which is -3, and of course that's negative. So we have negatives inside the interval from 0 to 2, because that's where x is equal to 1 lives. And now I can use the rules for multiplicity. If I go from 0 to 2, and I cross the 2 here, because 2 had a multiplicity of 1, that's odd, and that means it changes. So it's going to be plus on the other side of 2. And then if I cross over where x is equal to 0, x equals 0 has a multiplicity of 2. That is even, which means the signs do not change. And so they are negative on this side of x equals 0. They were negative on the right side. They stay negative on the left side because there's no change. Finally, we cross over from the right side of -2 to the left side. The multiplicity of x equals -2 was odd, so it changes to a positive. And now we can use the sign chart to solve for the inequality. The inequality is less than 0, and it's strictly less than 0. So we're looking for the numbers where it is strictly less than 0. So that's going to be between -2 and 0, and from 0 to 2. It does not include any of the endpoints because we are not talking about less than or equal to 0. We're talking about strictly less than 0. So it's -2 to 0, union 0 to 2. Notice that we had to jump over x equals 0 because x equals 0 is a point where it is undefined. Example number 6. Solve the inequality. 3x minus 2 over x minus 4 is greater than 3. All right, so to solve this, the first thing I'm going to do is move the 3 to the left side. It comes over as a negative. I'll leave a little space because I'm going to add something in there. And that makes it greater than 0. Now I need to get a common denominator. The common denominator is x minus 4. So we're going to put x minus 4 over x minus 4 to create this common denominator. That gives me 3x minus 2 minus 3 times x minus 4 over x minus 4 is greater than 0. Which is 3x minus 2 minus 3x plus 12 over x minus 4 greater than 0. The 3 x's cancel. That gives me 10 over x minus 4 is greater than 0. So this is the inequality that we need to solve. So that was step 1. Make sure you have 0 on one side. Step 2 is to find all the partition points. Well, there are no x's in the numerator, so there are no zeros of the rational function. But I can set the denominator equal to 0 to produce x is equal to 4. Step 3, let's create the sign chart. So the sign chart only contains the one number of 4 where it is undefined. Now don't forget which inequality you are testing. You are testing this inequality right here because it's the one that we simplified down to where it was a comparison of 0. It's greater than 0. So we're looking for the positives. So when we go to test, we're actually going to test inside this new inequality. So I'm going to test at x equals 5 because why not? And so that gives me 10 over 5 minus 4, which is 10, which is positive. So at x equals 5, we produce a positive. That is the positives for the interval from 0 to infinity. Because the multiplicity of x equals 4 was 1, it changes when we cross over x equals 4, so it changes to a negative. And finally, we solve the inequality. We're looking for greater than 0. Greater than 0 means positive, so the answer is 4 to infinity. It does not include 4, and even if it were greater than or equal to 0, it still wouldn't include 4 because 4 is undefined. Example number 7. The concentration C of x in milligrams per milliliter of a drug in the bloodstream x hours after it was injected is modeled by C of x is equal to 20x over x squared plus 1. Find the time frame for when the concentration of the drug in the bloodstream is less than 6 milligrams per milliliter. All right, so first we have the formula here, and we want to know when the concentration is less than 6. So that would be concentration, C of x, is less than 6. So here we have the inequality we are trying to solve. 20x over x squared plus 1 is less than 6. To solve this inequality, I need to get 0 on the right side. So I'm going to move the 6 over. It comes over as a negative. Leave a little space because we're going to try to get a common denominator here. And yes, the common denominator would be x squared plus 1. And this gives us 20x minus 6x squared minus 6, because the negative distributes, over x squared plus 1. It's less than 0. Let's rearrange the numerator into the correct order. So it would be negative 6x squared plus 20x minus 6 over x squared plus 1 is less than 0. And this is the inequality that we are trying to solve. So that was step 1. Step 2, find the partition points. So I'm going to take the numerator and set it equal to 0. And then see if you can factor it. Well, I notice that all of the coefficients are even, and I'm not a particularly big fan of the negative in the front. So I'm going to take out negative 2. And that's going to leave me with positive 3x squared minus 10x plus 3 is equal to 0. And from that, I can see how to factor this. I'm going to have 3x and x, and then we're going to have 1 and 3, and they're both negative. And you can double check that the middle terms, when they multiply together, do give us negative 10. Now I set each factor equal to 0. And solve for x. Well, there are no x's in the first one, so there's no solutions there. But in this middle one, I get x is equal to 1/3. And in the last one, I get x is equal to 3. Next, we need the partition points that come from setting the denominator equal to 0. So x squared plus 1 is equal to 0. So we have x squared is equal to negative 1. And, well, x squared would be I, but we're not using imaginaries. So we'll just say that there are no solutions. Let's create the number line. Now we do need to be a little bit careful here. We don't want to use an arrow on this left end. The reason for that is because this is an actual physical process, the act of administering a drug. And that has to start at some point. And so the concentration of the drug before the drug was administered does not make any sense. And so we start this at x equals 0. The other numbers are perfectly fine. 1/3 and then 3. And these are zeros and zeros. But what this does affect is the numbers that you can use to test inside of the function to determine the signs. Because you don't want to use any negatives here because those don't make any sense. All right, let's pick a test value. And I will pick x is equal to 1. So we're going to plug 1 into the function. It's the original function, or you could use the factored version. It's your choice. But it's negative 6 times 1 squared plus 20 times 1 minus 6 is equal to negative 6 plus 20 minus 6, which is plus 8. So it is plus right here. So we have pluses where x would be equal to 1. Which is between 1/3 and 3. The multiplicity of each of these was 1. That's odd, so it changes every time you cross over one of those numbers. So when we cross over 1/3, it changes to a negative, and when we cross over 3, it changes to a negative as well. All right, let's go back to our inequality. And it looks like we are solving for less than 0. That means negative. So we look at the number line and we determine where the numbers were negative. And the numbers were negative from 0 to 1/3, union 3 to infinity. And so that's the time frame where the drug concentration was less than 6 milligrams per milliliter. All right, thanks for watching.